Hi there and welcome back. Today I would like to talk and show you how to use some of these SD card modules, and they come in a variety of selections and shapes, but in general they are very common and commonly used. They are used for data logging for a personal purpose and not so much a industrial purpose. For industrial use I would never recommend these types or even Arduino, but they would definitely serve as a very good introduction, and you'll get a know-how of how they work and how to use them. And even if you should get your hands on a professional data logger, you will now know how it works. However, a professional data logger does not have pins exposed, and most likely you won't be able to touch anything of the hardware. You will only be able to touch some buttons. However, this is excellent to do some energy optimization in your house or greenhouse or wherever, because you can measure around the clock and you can measure whatever you want, temperature, light, anything you want. So it's a great device for personal data logging or some sort like that. It has a lot of uses. Today we're going to use this module, a small 4GB SD card, and a Uno. Not a Arduino, this is a Uno. And some wires. And I'm going to start by using the Arduino IDE because it comes with some brilliant examples on how to use SD cards and SD libraries. And it's already included if you have the Arduino IDE. So we're going to use the Arduino IDE example to develop something we can play with. So let's get right into it. Okay, the first thing I want to do is open my Arduino IDE as I have here, and then I want to find a sketch where I can use my SD card. Luckily for me, the Arduino comes with such examples, so I just hit up File, Example. I scroll down to the third part. You can see the sort of lines, at least in this version. I'm on 1.6.8 right now. Examples, and way down here we can see we have something called SD, and we have different examples. Right now we're just going to choose the one called card info, which are going to allow us to check if there is a card connected to the Arduino. I open that up. Oh, it opened on another screen. Here we go. And luckily for us, it shows how to connect the pins. So let's jump right into connecting the pins. As you can see, I have my Uno. It's not a Arduino. This is my Arduino. This is a Uno. Remember the difference. Got a card reader and a SD card. Funny thing about these card readers and writers like this one is that it has two rows of pins, as you can see. However, we're only going to use the right row. The left row is completely unused. It's not connected anywhere. Even if you try to measure something out, nothing is connected. And I believe the reason for that is because the manufacturer of this device has replicated some other device that looked like this, and it had two rows of pins, because otherwise you would just add a single row like this over here. I have no idea, but what I can recommend using that extra row for is for stability. If you're going to include this in your product, you can just solder on these pins and use it to hold this card in place. That's very useful. Anyway, let's connect it. We have several pins. We have ground, 3.3 volts, 5 volts, chip select, MOSI, clock, MISO, and ground. MISO means master in, slave out. Clock is the way these two boards are going to synchronize together. Remember, it has a crystal and they need to run at the same speed, else they won't be able to talk to each other. Then we have MOSI, master out, slave in. And then we have chip select. MOSI and MISO is basically also referred to as transmitting and receiving, just like we use right here. As you can see, it says RX and TX, and over here RX and TX. That way they are going to communicate as well here. So let's hook it up. First thing, I'm going to start from the top and work my way down. So first of all, we have ground, so pin in and pin in the Arduino, Uno. Then I have 3.3 and 5 volts. I'm going to choose to use 5 volts, but you can use 3.3. So power in 5 and over to 5 on the Arduino. So we have one empty now between these two. The next one is called CS. I'm going to put a wire into the CS pin. And then I'm going to check with my sketch that it says in the example that CS should be connected to pin 4 for this particular example. But this one you can actually connect wherever you want, because we can change that in the code under the point called chip select. So we just put it in 4 for now. I'm going to take the yellow wire and put this one in MOSI. Check my sketch again. It says MOSI should be put in pin 11. I put it in pin 11. Next up I have SCK. Wire in. I check my sketch. It recommends I use SLK, but it says SK. It's the same thing, don't worry about it. And I'm going to connect that to pin 12. The last wire, the green one, is going into MISO over here. And I check my sketch and it says pin 13. I connect it to pin 13. Finally, I plug in my SD card. You need to make sure the lock is not locked. Now it's locked. Now it's not locked. What is going on inside is it's actually breaking a connection between some of these pins. So plug it in and we are ready to go. Quite simple, right? Okay, now that we have everything connected, it's time to do some testing. So I'm going to power up my Arduino. We got the sound and it's time to test it out. So here we go. We have the code example still running. We haven't changed anything. We haven't changed anything on the card. I'm just going to check that we have the correct settings. Yes, it says Uno and we're on COM8. Let's upload. And just give it a minute to upload. There we go. And let's open the serial monitor. Oh, and instantly it responded. Initializing SD card, wiring is correct and card is present. Card type is SDHC, volume is FAT32, and it talks about the size of the card in both bytes, kilobytes and megabytes. Files on the card, it says there's two files. There's one called number and there's one called data log. These are two files I have been using to test with and will continue to do so. Apparently it works. So what's next? Well, next up is actually writing something to the card and testing if it works. So we have two options now. We can use one of the examples because the wiring will be the same, so we don't have to change the wiring. So open up examples under SD and you can see there's something called data logger. Let's just open that up. There we go. And it's the same pinout. Everything is the same except the code further down. We can see it initializes the card. It doesn't use any special libraries. It's as is. There's nothing extra needed for this. But everything is in the code you write to make it work. So we have our setup loop and it does nothing but accept preparing the SD card, and we have some new commands. You can see we have this one called SD. So we have this function called SD, and it has some sub-functions. One of them is called begin. So if you remember, when we are writing to the serial monitor, we also write serial begin. The same with the SD card, we are going to write SD begin. That's basically it. And further down we just do some different things. You can see they have connected, all of this is just a sensor, this part. They have connected a sensor to the Arduino, and they're going to write the sensor data to the file. But what's interesting for us is this part right here. We have this one called file, data file equals SD open, and we have a file name and a file command. We set file write. And then we just fill this thing called data file we defined up here with data, and then we serial print it, and that's it. Okay. To analyze this further, I think it would be much easier to write our own example and actually write our own text. So instead of using a sensor and connecting all these things, we're going to do our own thing. So I'm just going to delete all this. So all we have now is an empty main loop, or loop if you want. And if we look in the code, we're just going to run over it really quick. So first one, we have a comment that says open serial communications and wait for port. Get rid of that. And it waits for USB. Yeah, that just means nothing will happen until we have a serial monitor checking on it. And then it's going to write, and this part is very important. This is the part that says if the SD card is present. So you can see it says exclamation mark, which means not or inversed. SD begin, chip select. Chip select is on number 4 right there. Serial print, card failed or not present. Well, that's just some text we add to it, but it could be a number of problems. If one of the wires is not connected, we would also have a problem. But yeah, we just leave it at that. That's just an error we get. If it's a success, we get the line card initialized. Perfect. And now we can start our own thing. So let's get rid of the introduction as well, so we don't clutter up too much. So this is our entire code that is going to enable us to work with our SD card. That's it. So I'm going to define new things right here, just so we can see it. And I'm going to define a new integer, and I'm going to call it a number. I'm going to say number is equal to 0, end line. And I'm going to say int max count equal to 1000. No, let's just skip that. Let's just leave it. Let's keep it very simple, okay? So right now we have a variable called number. It's an integer, and we're going to simply increase it by 1. So we could do this, or we could do this. We're just going to do that for now. And we are going to increase the number by 1 each time the loops run. And I want to delay the loop by just a slither of time, just giving the system time to follow up. If I'm not including this, sure, it might be able to count to 1000, but it might also skip one of the data writes. So just to be safe, we're going to do it like this. Next thing I want to do is write this number to the SD card in a file. So I'm going to create a new function of void called write, and I'm going to include a command in this, or integer, called this number, like so. Meaning whenever I type write, I need to include a number in parentheses, and write is a bad name. As you can see, it turned orange. That's not good. So let's call it write number. There we go. No? Let's call it write SD. so we know we are writing to the SD card. So the first thing we want to do is define a file we want to work with. So we say we want to write to this file. So file, and it's a data file. It's just a name. This part is just a name. The first part is we're saying to the system, the file called data file is equal to SD open. Again, we are going to open a connection to the file and give it a name. If the file does not exist, then the system will create a new file for us. And we're just going to call it number. Sorry, that's a Danish word. Number text. And then I'm going to write or give the command what's going to happen now. Well, we're going to write to the system. So file write. There we go. That's it. We are almost ready. Next thing we want to do is actually write to the file or check if the file is present. And this is where I get a bit confused. But let's do it. If the data file, nothing more, and when you don't type anymore, it just asks if it's there. Then we're going to data file, print line, and we're going to print the number, this number, and do nothing else. And then we're going to data, oh, I need to remember the F file, close, means we're going to stop, and that's it. This should both write the numbers to the file and run it. But before it will write, we need to up here update the command. So we are going to write or call the function, okay, number. So what will happen now is the program will start up, and once we open the serial monitor, it will begin counting. This is basically just a counter. You can see the first number is 0, and then it instantly goes in and adds to 1. When it's 1, it's going to call this command called write SD 1. Then it's going to jump down here and take this number, open the file called number text with the instructions to write, and then it's going to add a line with this number, meaning it's going to put number 1 in, it's going to close the file, go back up here, wait 10 milliseconds and start over. Add another number, which is 2, write the number, and it's going to continue, and we would end up with a list of numbers 1, 2, 3, etc, etc. Let's compile and check if the code is okay. It appears to be okay, otherwise it would already have made suggestions about it otherwise. So let's upload it to the Arduino. And here's the clever part. If we are not going to do anything right now, it's not going to start to write. It's not writing right now because it's waiting for serial port to connect. So whenever, just as soon as I open the serial monitor, it should start to write. There we go. Card initialized, that's the command we wrote right there. And it's actually writing the numbers to the card now. But what's the problem? Well, we can't see what's going on. So let's fix that. I'm just going to hit the reset button on the Arduino to prevent it from writing any further while we're changing the code, okay? So what would we like? Well, we would like some feedback into the system letting us know what is the number and what has it written. So as soon as the command write SD, I'm going to include a few things right after it. First I'm going to type serial print. I'm going to add parentheses, just a space. No, I'm actually just going to type in number like this. Then it would put the number into the serial monitor, okay? Excuse me. And then we're going to write to the SD card. And then I'm going to write serial print a line dot dot dot, okay, and that's it. Then we should get the numbers shown on screen, and we should get an okay after it's done writing. So let's upload that code. And let's open the serial monitor. Oh, it's still busy. Let's try now. And you can see we're shown the numbers it's writing. If I hit the reset, it's going to start over. And that's it. I can now take the SD card and put it into my computer and read the text file. But I have already done something like that, so let's get rid of that. There we go. This is the old one. Remember, I showed you there was a file called number, and this is actually it. It looks like this. It's just adding the numbers all the way down. Very simple. And that's a way to create a very good data logger. So you are able to write your own software that would save data to an SD card, and you can, if you want to make something where you're tagging multiple sensors or something, you can just add a comma and you would be able to import it right into Excel or some other software like that and use it to make curves and other sorts of awesome graphics for your projects. Hope you enjoyed this small instruction. If you liked it, please thumbs up, it helps me out, and subscribe, and I'll see you next time. Thanks for watching. Bye.